Hello everyone and welcome again to our videos in Bazara Aviation Academy. Today inshallah our class will be about the exhaust system, and this class will be the end of the exhaust system. Before we start our class today, I want to answer the last homework. The last homework was why exhaust system component made of nickel cadmium alloys or heat resistance or corrosion resistance alloys. The answer is due to the corrosive nature of exhaust gases and the wide range of temperature that system experiences. Today, before we start our class, I hope by the end of this video, all the students can able to understand steps those should be made during inspection of the exhaust system. Also, can understand the failures those appear in the exhaust system. Also, understand construction of the turbine exhaust system and understand the meaning of thrust reverser and what's the benefit of the thrust reverser. Also, and this is the last one, how to prevent noise in the exhaust of turbine engine system. After understanding the types of exhaust system and of reciprocating engine, you must be familiar how to make maintenance to the exhaust system, because in the event of exhaust system failures, that it will result catastrophic conditions like carbon monoxide toxicity. How carbon monoxide enter the aircraft? If we back together to Airframe Book chapter 14, we will find that there are some diseases that affect the human on the aircraft, such as hypoxia and carbon monoxide. Carbon monoxide will enter the aircraft in event of shroud or muffler failures. And when the human will inhale the carbon monoxide will displace the oxygen from the body, and that will causes to death. The second one, or the second catastrophic results, is engine or aircraft fire. After that, it will decrease the engine performance. So the exhaust system must be in safe condition during flight. Now we will know some steps that must be taken before inspection or before maintenance of our exhaust system. And you must never use galvanized or zinc plated tools, and never mark the exhaust system components with lead pencils. Why we have to don't do this? Because the zinc, lead and galvanized material will affect the exhaust system. How that will be? Because when the exhaust system component heated, they will absorb these three materials, and that will affect our exhaust system. So you must don't do these two things. Exhaust system inspection. You have to put in your consideration when you're making an exhaust system inspection, you have to look for dents, cracks, missing parts, because these damage will permit the gases to escape. When gas escape the exhaust system, it will appear as a flat gray or a stony black streak on the outside of an exhaust system. Here when we say to the arrows, here we have in the exhaust system, like this. You will find these areas where the air will escape, and we have to focus on this area, because if we have an air that escapes from it, you will find it as a stony black streak, so as a gray or black areas like this. We will find it in these areas. Also, if you can't inspect a component of exhaust system because it's hidden, you have to remove the part and inspect it. Like here we have exhaust system of opposite reciprocating engine, and if we have hidden areas like we have here behind this and also when you see here it's hidden and you can't reach to these areas, you have to remove the part and inspect it. Also, you have to focus during inspection the welded area. Here we have unwelding areas on the exhaust system. You have to focus on it. Why we have to focus on this area? Because the expansion and contraction when exposed to heat. You must inspect the muffler and the shroud or heat exchanger, because if these components fail or crack, they will permit exhaust gases to escape directly into the cabin, and that's like what we talk about it in the first of our class today. If our exhaust system has a turbocharger, you have to inspect the turbocharger. Do you remember the turbocharger? And where is the location? Of course you know, because the turbocharger is located in the end of our exhaust system. And when we have a turbocharger, of course we will have a waste gate. So we have to inspect the turbocharger, because in event of turbocharger failure, the waste gate will be in closed position, and that will affect our reciprocating engine. If there is a component of exhaust system has to be cracked or dent, you have to replace it with a new one, especially in the welded area. Now we arrive to section B. In section B we will talk about the exhaust system of turbine engine. As we see here, we have exhaust system of turbine engine, and we talk about that in chapter 3 in turbine engine. Here we have the exhaust cone, tailpipe and exhaust nozzle. These are the three components of the exhaust system. And we have in the exhaust cone, it consists of inner cone, outer cone and struts. The inner cone will collect the air from the turbine and will deliver it to the outer duct. After that we have the strut. Our strut is used for support the exhaust cone. After that the air will go from the outer duct or from the outer cone and deliver it from the tailpipe to the exhaust nozzle. In the exhaust nozzle we have two types. The first type of the exhaust nozzle is the convergent nozzle, and as we see here is a convergent. And after that we have the convergent divergent nozzle, and this is the second type of exhaust nozzle. Thrust reverser used on transport aircraft that use turbofan or turbojet engine. They use the thrust reverser for providing braking and directional control during normal operation or normal landing. Also used for providing braking and directional control during emergency landing. And the last one used for backing an aircraft out of the parking. The maximum reverse thrust capability is always less than the forward thrust capability. Operating with thrust reverser at low ground speed can cause compressor stall due to re-ingestion of the hot gases. It can also cause ingestion of a fine sand. Here we have our thrust reverser, and we will see how the thrust reverser tool works. When we see here, the door will open and will prevent the gases from go outside. They will back for the forward, and this the operation of our thrust reverser. We have three types of thrust reversal system, and they are: the first one we called clamshell doors, as we see here. This is called clamshell doors. And the second one we have is called bucket doors, as we see here. This is the second type, and here we will see how it works. And the last system we have it called blocker doors, and this our blocker doors and used in turbofan engine. Here we have the runway, and here we have the aircraft will approach on the runway, and it will use the thrust reverser. We have two safety gates are built into selection of reverser thrust. The first one, thrust reverser cannot be activated until the aircraft has the weight on the main wheels. And the second one we have is here we have our throttle, and here we have the control of the thrust reverser. Here our thrust reverser control, and here we have the control throttle control. And here we say thrust reverser cannot be selected until the throttle lever at the idle point. How to prevent the mixture of the sand to enter our thrust reverser? By two ways. The first way called mechanical blockage, and the second one called aerodynamic blockage. The first one, in the mechanical blockage, we see here in this figure a calm shell door. We have here the door will close, and when the door will close it will make an angle. This angle will make the air to direct in this way and will prevent any air will come from here with the mixture. So this type is placing a mechanical block that rejects gases leaving the engine and changing its direction at a certain angle, and this blockage is installed extremely or externally at the end of the engine, at the end of our engine, and this type is called clamshaft or clamshell doors. The second one we have aerodynamic blockage. In this type, like this here we have a clamp, we have the second type and it's called aerodynamic blockage. This inhibitors inside the engine in the gas stream close the outer cowl side, the side doors open in the engine. At the same time, vents blade, like this we have a vents blade block the exhaust gases outlet and prevent to any gases will come in this side and prevent what we called of sand or mixture. At the end of our section, we will know how to reduce noise of turbine engine, especially turbojet engine. We can do this on ground by the first way we use this, and this called turbojet deflector, or as we mentioned in our book, it called blast fences. This used for reduce the noise of engine on the ground. And the second way we use this way, and this called hash. This hash used on the older turbojet aircraft and used for reduce the noise of our turbojet. Now, at these days, newer engines use a variety of techniques to reduce harmful noise. For example, some turbofan engines blend fan discharge air with the exhaust gases to reduce sound emission. Don't forget our homeworks. And our homeworks for today is which component of exhaust system will make engine backfiring in event of failure. Thanks for your watching, and I hope you understand the lesson. Goodbye.